This is the circuit actually we are having, the continuation of yesterday's class. Here 5 amps is entering current and 4i2 is also entering towards the node. So this is acting like a common node, sorry, one node, and this is the reference node or common node. Okay, two nodes are there. This is node. So here for this node, two currents are entering. You can see the direction of 5 amperes and the direction of 4i2. So that's why I am writing the current directions as towards the node, that is 5 plus 4i2, sum of currents entering. These are the entering currents. Okay, and the remaining currents, that is as i2 and i1 is there, that those are the leaving currents. That's why I have written outside of that one, right side. Okay, by making use of this, and the thing is here, because of the parallel circuit, the voltage will be same across any branch. So here let us continue this equation. 4i2 is there and i2 plus i2 is there. If I shift i2 this side, you will get a 3i2. No need of writing this here. Okay, this is 3i2 minus i1 is equal to minus 5 I got. Let me go for uh, 1 ohm branch. Okay, just you apply Ohm's law, that is I is equal to V by V by R, and
V by
here
R.
V by R. Here I am having the voltage V like that only, because we don't know, the unknown voltage is V only, and the resistor, you know, no, through I1, and the resistor value is through I1. The resistor is what? The resistor value is 1 ohm.
1.
Okay, 1. So I
1
got
ohm.
I1 as V. I1 as V. I1 is equal to whatever the current is, nothing but voltage itself. And let me check I2. Similarly, I2 is equal to, similarly, I can write I2 is equal to same voltage, no, V by R value. R value is 6. R is
6.
6. Okay. 6 I have written. So I got the two equations. Equation 1. First one is I got as 3i2 minus i1 is equal to minus 5. And this is the equation number 2. Just I am substituting the i1 and i2 values in equation number 1. I1 is replaced by V and i2 is replaced by V by 6. When you replace, you will have only one variable. If only one variable is there, we can determine that value. That's why I'm substituting 1 and 2, I1 and I2 in the equation number 1. So when I substitute, you are going to have 3 into, in the place of I2, I can write V by 6 minus V, that is I1 is replaced by V, is equal to minus 5. When you do the LCM, you are going to get V is equal to 10 volts. So after getting the voltage V, we can get the values of I1 and I2. Okay. Only thing is we need to find the values of unknown values. What are unknown? I1 and I2 only, no? So we need to find I1 and I2. What is I1? I1 is nothing but V by R. What is V? Already we got 10 volts. The 10 is nothing but I1 itself. And what about I2? I2 is V by 6. 10 by 6 if you do, you will going to get 1.67. This is the answer. That means here which one we have considered, dependent source and independent source. What is independent source here? 5 amps is the independent, and this arrow mark is there, no, diamond shape is there, that is the dependent current source. Okay, so what is the dependent current source value? 4 into I2. 4 into I2 means the value of that, the value is 4 into 1.67. That is the answer you are going to get. Okay, but the thing is we need to find only I1 and I2. That's enough. Is it clear, all of you?
Yes,
Is it
sir.
clear, all of you?
Yes,
Yes,
sir.
sir.
1 minute. Okay, okay. Let me go for other. Okay, we will see voltage division now. Okay, voltage division formulas. Two more formulas we are going to see now today. One is voltage division, another one is current division. Okay, how voltage division? Voltage, we know that voltage divides in series or parallel. Voltage divides in series connection only, no? How it divides? Let me go.
Series.
Okay, this is the resistors connected in series R1, R2, so on Rn, and connected with the voltage source Vs. Okay, Vs is applied for this circuit. If we, this is a series branch, current will be same throughout the branch. That means current flows from higher potential to lower potential. Higher potential means positive, lower potential means negative. Okay, it starts from the direction from positive to negative. So if I apply KVL, if I apply KVL, KVL, Vs is equal to, Vs is equal to source voltage is equal to remaining voltage drops, sum of voltage drops, sum of voltage rises is equal to sum of voltage drops. This is minus and plus is voltage rise, and these are voltage drops. If resistors are there means voltage they are consuming, no, this is voltage drops at each resistor, plus minus like that. Okay, so I have written Vs is equal to V1 plus V2 plus so on Vn, which is nothing but what is V1? We know V1 is I into R1 only. No, just apply Ohm's law. V is equal to I into R.
IR.
Ohm's law. If you apply V is equal to IR, what is V1? V1 is nothing but current is I on I itself only. No, I is I itself. What is R? Voltage drop across V1. R is R1 only. No. Similarly, V2. V2 is I into R2 and so on and so on. What is Vn? Voltage across Rn. That is I into Rn. Okay. This is the equation I am going to consider as equation number 2, or if I can consider Vn is equal to I into Rn as equation number 2. Now here this equation is there, no? See the equation number 1. Equation number 1 is how the resistors are connected. All are connected in series. If they are connected in series, simply I can write, I can add all the values as R1 plus R2 plus so on Rn. Simply I can replace it by R equivalent. You are going to get supply voltage Vs is equal to Ohm's law. Supply voltage Vs is equal to I into R. R is R equivalent. So from this I can write current I. From this I can write current I is equal to Vs by I is equal to Vs by R equivalent. I is equal to Vs by R equivalent. Okay. So this is the equation number 1. This will be equation number 1. So what I am doing is I am going to substitute this equation number 1 in equation number 2. if i substitute if I substitute that equation, what you are going to get? Here equation number 2 is there, you can go through it. That is Vn is equal to I into Rn is there. What is I am replacing this equation number 2 will become Vn will be Vn itself. In the place of I am writing Vs by R equivalent, Vs by R equivalent by into Rn. Okay, this is the equation you are going to get. Simply we can say that if you want, why we are doing this voltage division? Without knowing the current also, without calculating the current also, we can get the value of voltage at particular resistor. Okay, voltage at particular resistors can be determined by making use of this formula. What is the formula? Suppose if you want to measure the voltage across resistor Rn. Okay, nth resistor, at nth resistor you need to know the voltage. So what is the thing? Directly you substitute the formula as total voltage. What is Vs? Vs is the total voltage into particular resistor. What is particular resistor? Nth resistor is particular resistor only, no? That is Rn by what is total resistor? That is R equivalent. Okay, suppose if so this is the formula, this is the standard formula you can write. Now if you want to write the voltage across fourth, voltage across second resistor, you tell me now. V2 is equal to V2 is equal to Vs into V2 is equal to Vs into R2 by
R2
R
by
total,
R
R2 by
equivalent.
R1
R
plus
total,
R2.
like that you
R
can do.
equivalent.
Okay, okay, this is the formula. Everyone write down. Okay, everyone write down this formula such so that we can go with the other problems. Vn is equal to Vs into just R equivalent. You can write here also, ma. Rn by R equivalent. It will be easy if you write like that. I'm clearing all. Okay, simply you have to go through this. Vn is equal to total voltage into particular resistor by particular. So when you are writing for that resistor means particular resistor only you have to say. Suppose nth resistor is there means nth resistor will nth voltage I want to find, nth resistor you need to consider. Okay. Now by making use of this formula, all of you work out what is the voltage across A and B. Please tell me the answer, all of you. Find the voltage across VAB. This is A and this is B. And 50 volts is there. No need of finding current, no? VAB is equal to VAB is equal to formula. What is total voltage, ma? How they are connected? See, voltage divides means series connection only, no? 5 and 10, how they are connected? Series. So you can apply voltage division. Total voltage. Total voltage, how much?
50.
Total
50.
voltage.
50.
Write down the formula, all of
50.
you. Write down the formula. 50. Particular resistor, tell me. What is a particular resistor? Write down formula and do it. Particular resistor. AB. AB. At AB, what is the resistor you are having?
10. 10.
10 ohms. 10 ohms by total resistance. How they are connected? 5 and 10, they are connected in series.
Series. Series.
5 plus 5 plus 5 plus 10. That is 15. Okay. If you do 5 ones, 5 twos are 10. This is 5 threes are 15. That is 100 by 3. 100 by 3, how much? 33.333
33.33.
volt. 33 volt. This is the voltage across particular resistor, that is at VAB. 33 is there. So remaining voltage, how much it is? Remaining voltage, that is 16.666. It will be at 5 ohm resistor, because total voltage will be consuming by those two resistors only, no? So at remaining voltage will be at 5 ohms. Is it clear, all of you?
Yes, sir.
Now by making use of that, shall I go with next slide? Finished, everyone?
Yes, sir.
Okay. Write down. Find voltage across A and B in the following circuit. Find voltage across A and B in the following circuit. Tell me the answer. 100 volts is given. 154. They are connected in series. Now I am taking two resistors in consideration, that 5 and 4. So I want voltage between 5 and 4. Okay, voltage drop, total voltage drop between 5 and 4. You just apply the formula. You are going to get 90 volts. Okay, that is VAB is equal to total voltage into particular resistors. 5 and 4, how they are connected? Series only, yes or no? Please respond. 5 and 4, how they are connected?
Series. Series.
Series means you have to add that value, that is 5 plus 4. Okay, particular resistor is 5 plus 4 by total resistance. What is the total resistance?
10.
10 sir.
10.
12.
Okay,
12 Raj.
10.
okay, it
10.
is cancelled. Not 12, it is 0. It is cancelled. 0 and this 0 will cancel here. Okay, this is 0 and this 0 cancelled. So this 10, that means cancelled. Here 9, 5 plus 4 is 9. 9 into 10 is 90.
90.
Okay, not 12, it is. Finished, everyone?
Yes, sir.
Okay, now we will see current division. Okay, voltage division is finished. We will go with current division. Current divides in series or parallel, tell me. Current
Parallel.
divides in parallel connection. Very very good.
Parallel.
Let me go. Okay, this is the voltage source I have taken. So because of this voltage, current starts flowing in the circuit here, because of total voltage, total current will be flowing at this node. At this node, this is the node. Node means nothing but intersecting point only, no? At this node, two currents will be, because two roots we got. Two root is nothing but two path. PATH, two paths. So two paths means two currents will be there, and this, so that's why two current will be dividing, that is I1 and I2, and again coming back as I total. Again that will sum up and come. That means current will be circulating. It will circulate in the circuit itself. Always the current will be circulates when the supply is there. Till that, current will be circulating. Circulating means cycle only. I total current will be flowing based upon the resistor's value. If resistor changes, automatically the current also changes in the circuit. Okay, so now you apply KCL. I total is there. You just Ohm's law, V is equal to I into R. So I is equal to V by I is equal to V by R. By making use of this, I total is, this is the I total. I total is Vs by total resistance. Supply voltage is Vs. Total resistance is R equivalent. How they are connected? These two resistors, series or parallel? This R1 and R2, how they are connected?
Parallel.
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 Parallel. So if they are connected in parallel, what you have to do? Product by sum only, no? That
R
is R1
into
R2 by R1 plus
product
R2.
by sum.
Okay,
Yes, sir.
that is the R1 R2 by
R1
R1
plus
plus R2. That is, so I got this one. Now I am going to have the formula, that is I total is equal to, I total is what? Vs by R equivalent only, no? Equation number one. Equation number one is there. Equation number two also we got. I am substituting equation two in one. If I substitute two in one, what you are going to get? I total is Vs by R equivalent. R equivalent is the value. This value R equivalent is in denominator, means what you are having R1 R2 is there, no? That's why R1 R2 is in denominator, and this will move to R1 plus R2, move to numerator. So that is the thing we got actually. I total is equal to Vs by R1 R2 into R1 plus R2. Now we are going to find I1 and I2, okay, by substituting these values. So what is Vs actually? Here this is a parallel circuit, yes or no? This is a parallel circuit. So if it is a parallel circuit,
yes, sir.
voltage will be same, yes or no? Voltage across this resistor R1 and voltage across R2 will be same. So I can write Vs is equal to Ohm's law. V is equal to I into R only, no? I into R. What is at resistor 1? That is I1 R1. At resistor 2, voltage is same, means I can write I into R. That is I2 R2. Okay. I can replace Vs by, I am replacing Vs by I1 into R1 to find I1, and I can replace Vs by I2 into R2. Two things I can change. Okay. So if I change, all of you write this as in side. This one is finished. Vs is equal to I1 R1, which is equal to I2 R2. I'm going to next page. So here Vs is equal to I1 R1 is equal to I2 R2. Substituting this term in this, I am going to get I total is equal to, I total is equal to, replacing Vs. This is the Vs. Vs is replaced here. So replacing Vs by I1 R1. So if I replace Vs by I1 R1, R1 R1 get cancelled. I will have I1 by R2 into R1 plus R2. But I am interested to find the value of I1, no? Individual currents I need to find, that is I1 and I2. So if I find I1 from that equation, R1 R1 is gets cancelled, no? Are you following? This R1,
Yes,
Yes, sir.
yes, sir.
this R1 is gets cancelled. Okay, R1 and R1 is get cancelled. I want only this I1. So I am writing I1 here. What happens to this? I want to shift, I have to shift all these values, no? If I shift, what you are having? That is I total. I1 is equal to I total into this R2. Denominator will become numerator. I total into R2 by R1 plus R2. Okay. Similarly, if I replace this Vs, okay, if I replace Vs as this one, if I replace with Vs as I2 R2, if I write I2 R2, I am going to get as, if I replace I2 R2, I am going to get as I2 is equal to I total into R1 by R1 plus R2. Here for I1 I got opposite resistor R2. If I take I2, I am going to get R1. That means previously I got that resistors as, okay, previously for voltage divisions I got the resistor values, okay, particular resistor I got. But in this current division, what you are going to get, I1 is there means opposite resistor you are going to get, I2 is there means opposite resistor, not particular branch. We have seen, no, we have seen the diagram, yes or no? See this diagram. This is, I want to find I1 means total current into opposite resistor by this particular resistor. Here we got, no, that is sum of the resistors, opposite plus this one. One second. Hello, hello, class hello, hello, voice is audible,
Yes, sir.
please respond. Okay, previous what you got,
Yes,
Yes,
sir.
sir.
voltage
No, sir.
division we did, no, previous voltage division we did. What is the voltage division? If you want to find voltage across particular resistor, what is the formula? Total voltage into particular resistor by that R total, no? Here also, what you have to do this, if you want to find current in particular branch, total current into opposite resistor by particular resistor, that means total resistance you need to do, okay, just opposite that one we have got. No confusion for that, no confusion, that is okay. You can see that, you can see the formula. I will show you. This is the formula, okay. By seeing only you can write. See here, I want to find I1 here. This is I1. Now you tell me, all of you, I1 is equal to, what you got? I1, I want to find I1, no? I1 is equal to total current,
80 into
into,
what?
okay, for this
R
I1, what is the opposite branch?
R
Opposite branch is
R2
R2, no?
R2
R2 you need to write, opposite resistor by the total resistance R1 plus R2. This is the formula we got. By seeing only we can write. So by making use of this formula, I can write, I can find the currents in these branches. Okay. All of you write down, find the currents in I1, find the currents in the following circuit. Find the currents in the following circuit. So this is the voltage I have given, that is Vs. I am not giving the value, I am giving current only, because by making use of current we can get the values of I1 and I2. Okay, all of you write down the problem. I am taking two resistors in equal value. If I consider two resistors in equal value, what will be the current? Because voltage is same, resistors are same, will current will be same or not? If same resistors are taken, current will be dividing in same or different, tell me. 4 and 4 I have considered.
Same, sir.
Same, sir.
Same current. Same current means 12 will be divided into, same means how much, no? Dividing means same, how much? What will be the value?
6, 6.
Yes,
6.
6 and 6 and 6. 6 and 6 is the answer. Okay, you can verify that one. Will you are getting 6 or not? Check it. All of you check it. Substitute. I1 is equal to I total into R2 by R1 plus R2. What is I total?
Came.
I total is 10. 10, no? 12. It is not 10. I total is 12. What is R2? Opposite resistor is 4. R1 plus R2. 4 plus
4.
4.
4.
That is 8. Okay. 4 ones are 4 twos are 2 ones are 2 6 are So I1 how much you got? 6. Is it clear? I1 is
6.
6.
I2 also 6.
Similarly, I2 is also 6. Now what you do? You just replace 3. You just replace 3 and 6. Now I am replacing 4 and 4 as 3 and 6. Tell me the answers now. You just replace 3, 4 and 6, 4 and 4 as a 3 and 6. Now you tell me the answers. Current is same only resistors have changed. Same value 12 into the current is same means 12 into if I find I1, that is opposite is 6 by 3 plus
8, sir.
I1.
Sir, 8, sir. R1 is 8.
1
3
is
plus
8.
3 1 plus 6. 3 2 is 3 3 is 3 1 is 3
8, sir.
4
4, sir.
I2
I2
4.
is
Yeah.
4.
I1 is 8. I2 is
I2 is 4,
4.
sir.
I2 is 4.
So 8 you got. What will be the remaining? 12 is there.
4.
Initially 12 is there.
4.
Current. Okay. 8 is there means in order to get to 12, the remaining value is 4 only.
4.
8 plus 4, 12.
4.
Sum of currents entering is equal to sum of currents leaving. That is 8. Remaining current will be 4. And the thing is, you can observe that. You can observe that we can justify that. We know that if resistance is more, already we know we discussed the resistor. If resistance is more, current will be less. If resistance is
Yes.
less,
More.
resistance less, current more. This is the relation we have seen now. So here, what is the resistor in R1? Current how much you got
3.
for 3? For 3 for the
I1 is
resistor
I1.
8, no?
yes, sir.
8 you got. For resistor
I2
6,
4.
4 you got. 4. That means we can see that if resistor R is 3, 3 is a low resistor, no? Compared to that, current is how much? More. Here, 6 is there, no? 6 is there. Resistance is more compared to 3. Yes or no? If
Yes,
resistance
sir.
is more, current is less. We can verify that one also here. Okay, you can say that current always chooses low resistance path. Okay, current always chooses low resistance path. Low resistance compared to 3 and 6, 3 is the low resistance path. So maximum current will be flowing in that branch only. In that 12 amps, what is the maximum current is where it is going? 8 amps only, no? The maximum current will be flowing through the resistance. Suppose if R2 is more, if R2 is infinite, suppose if you assume R2 is infinite, what will be the current? Infinite is nothing but open circuit only, no? That means huge resistance will be there. So the total current will be flowing through R1 itself.
R1.
Is it clear? That means always current chooses low resistance path. Is it clear, all of you? Current division?
Yes, sir. Yes, sir.
Okay. So star delta is there in that in the next class we can discuss. You do series parallel combinations. We'll all of you draw the diagrams. Draw neatly. Okay. This is A. This is B. Write down. Find the equivalent resistance between A and B. Find the equivalent resistance between A and B. Between A and B. Equivalent resistance means what? Here there are many resistors. All resistors are replaced by only one resistor. Is it clear, all of you? All resistors will be replaced by only one resistor. That is the equivalent resistor. So how we will write? One, two, three, four, five. 5 resistors. This is 2. This is 2. This is 6. And this is 6 already there. How these two? How these two, tell me?
Parallel.
Parallel means product by sum only, no?
Yes,
So
sir.
this
Right.
is product by
Sir.
sum. 2 into 4 by 2 plus 4. Entama? How much?
4/3.
What is the value? 8 by 6. 8 by 6 value. In points
4.
you tell. 8 by 6, not 4 by 3. Just in tell me in the points. 1 point. All of you doing calci. 1 point.
1.3.
1.33.
1.33. Okay. What is this value at this resistor? 2 into 3. 2 into 3 by 2 plus 3. How much? 6 by 5.
1.2.
1.2. 2.
1.2. Correct only? Okay. 6 by 5. 5 ones are 5. Okay, 5, 1.2. So how all are connected now?
2,
How all
6,
are connected?
8, 14.
All are
Series.
connected in
16.
series. Only one
16.
resistor will be there. Okay.
1,
Tell me the answer now.
3, 5.
2 plus 6.